beautiful people, and welcome. This is apparently part 3. So if you noticed watching part 2 of arithmetic sequences, you'll notice that that video kind of cuts off. Turns out there was a technical issue that I was not aware of. But for those of you who reached out to me, I want to say thank you, or else I would have never known that it did that. We're going to continue with example number 3. If you haven't already watched arithmetic sequences video part 2, go ahead and do that. We did start talking about example 3. We're going to continue that conversation, but you also have example 2 and example 1 in that video. As always, disclaimer time, I am human. If I make a mistake, that is okay. Just let me know where the mistake occurs, so that way I may learn from it, you may learn from my mistakes. All right. Example number 3 says, if the second term of an arithmetic sequence or a progression, sometimes you'll see progression, sometimes you'll see sequence. If the second term is -1 and the fourth term is 5, find the ninth term. So in the second video, we kind of talked about how important it is to underline, circle. I encourage that. Translate things into verbiage that you understand, and that way the problem will be much easier to complete. Right, since we know that the second term and the fourth term, we know what those are, I'm going to go ahead and do this. Do you have to do this? Absolutely not. For me, it's just easier when I picture things, visualize things, so I don't have to use too much imagination if I have it in front of myself. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what we want. We have the second term. So a sub 2, give me a second here. I'm going to move my keys. All right, the second term, so a sub 2, the term in the second position is -1. The term in the fourth position, so the fourth term, a sub 4, is 5. And we want to know what the ninth term is. That's basically what the question is asking us. So we're a little bit bummed out because a sub 2 and a sub 4 obviously are not next to each other. We have the a sub 3 that is also missing. So this a sub 3 is missing. If we have two terms next to each other, for example, if we had a sub 2 and a sub 3, then we can find the common ratio between them, apply the pattern, and this problem becomes a lot easier. Because a sub 3 is missing, this problem jumps up to a different level of complexity because there is no a sub 3. We don't have a common ratio. So let's start out with our equation. Let me grab another color here. So for our equation, we have the regular equation of a sub n is equal to a sub 1 plus d times n minus 1. So in this problem, we're actually going to be using this equation multiple times because we're actually going to travel backwards so much back that we're going to go back into integrated math, one material or algebra material with the way we're going to solve it. Because we don't know what the common difference is and we don't know what the first term is. We don't know what a sub 1 is. We don't know what that is. We have two unknowns in our equation. We do know what a sub n is and what n is, and I'll show you why we know that. If we use the equation, a sub n is equal to a sub 1 plus d times n minus 1, we can substitute with the given information. For example, I know, here's my thinking bubble. Let me use a different color. Here's my thinking bubble. I know that a sub 2 is equal to -1. And I also know that a sub 4 is equal to 5. That's what they told me. That's what's given. So when I'm looking at my equation, I'm going to write that I do know what a sub 2 is. I still do not know what a sub 1 is. I still do not know what my common difference is. However, I do know what n is. So remember, n's must always match. So if n is now 2, this n also has to be 2. And minus 1 always stays the same. Now let's do the same thing, but with our a sub 4. So I have a sub 4 is equal to a sub 1 plus d times 4 minus 1. So because we have two unknowns, the a sub 1 and the common difference, we go back to solving this using system of equations. I hope everyone is doing a little mini happy dance because we always love system of equations, right? We're going to use system of equations. Don't panic. It's going to be okay. So before I start eliminating things, you're going to make sure to simplify this, distribute if you have to. So for the first equation, I'm going to write that here. I have a sub 2 is equal to a sub 1 plus, and I'm going to simplify the parentheses. 2 minus 1 is 1. 1 times d is d. For my secondary equation, I have a sub 4 is equal to a sub 1 plus d times 4 minus 1 is 3. Now, I really, truly hope some of you are screaming at me right now because you need to know that we know more information. We know what a sub 2 is. We already know that information. A sub 2 is 1. We already know what a sub 4 is. A sub 4 is 5. So let's rewrite these equations one more time. Now, if you already saw it in the beginning, you didn't have to rewrite it like this many times. You can just jump straight into substituting. So my final equations that I'm going to have negative 1 is equal to a sub 1 plus d, and I have 5 is equal to a sub 1 plus 3d. Now, to solve system of equations, your objective is to eliminate one variable first, solve for the other variable, then use that to solve for the original missing variable. So what we're going to do is we're going to eliminate my a sub 1s. How do you eliminate a sub 1s? We're going to subtract them because a sub 1 minus a sub 1 is 0. It's nothing. So I'm going to subtract all of the terms. I'm going to subtract 3 times. Here I have negative 1 minus 5. Here I have 0, so I'm just going to cross them out. And here I have d minus 3d. Negative 1 minus 5, that's negative 6. D minus 3d, that's negative 2. So I'm going to divide by negative 2 both sides here. And so d is equal to positive 3. So my common difference is a positive 3. We're doing a little bit of a happy dance right now. We know one more thing. We know the second term, we know the fourth term, and now we know what the common difference is. I'm actually going to back up here in my bubble and just write that my common difference is 3. That's kind of going to be my what we already know bubble. All right, are we done? Well, not really. So we do know what D is. You can do this many different ways. Since I know what the common difference is, I can start applying the pattern. So if I know that negative 1 is the second term, the third term would now be multiplied by 3. The second term, would be multiplied by 3 in order to get the third term. So 3 times negative 1 is, oh, I'm sorry. This is arithmetic. My head is in the geometric. We're adding, not multiplying. We're adding. Hopefully you caught that. That's a preview of what we're doing in the next video. All right, we're adding 3. So negative 1 plus 3, that is a positive 2. 2 plus 3 is 5, and etc. So I'm actually going to, you can find a sub 1 just following the pattern, but in this case, working backwards, or you can take one of your original equations. For example, I'll do this one here. Negative 1 is equal to a sub 1 plus d. We know that d is equal to 3 now. Ooh, you guys can't see, I apologize. Minus 3 both sides. So a sub 1 is equal to negative 4. take your D value, your common difference value, and just substitute it into one of your equations here that you're using to solve what a sub 1 is. Or you can just go backwards in your bubble. So a sub 1 is -4. Now, because you're being asked for the ninth term, again, you can just simply continue the pattern. It's not that, it's not going to take you too long. However, expect on a test or a quiz not to be asked for the ninth term, the fourth term, the third term. You're going to be asked for the 125th term. You're going to be asked for a term that's so far out that the only option you have is to continue to use your equations. So let's go ahead and solve using the equations what for the ninth term is. We're going to start again with our formula. A sub n is equal to a sub 1 plus d times n minus 1. A sub n is our term in the nth position. That means we want to know what the term is in the ninth position. We now know that a sub 1 is -4. We now know that d, the common difference, is 3. The n, again, n's have to match, so the n is 9. That's the term position. And the -1 never changes. I'm just going to highlight this real quick. Remember, n's always have to match. If you're unsure what n is, always look at the position number you're solving for, or the position number that you have. All right, so this a sub 9, that stays the same. We don't do anything with it because that's what we're solving for. Then we have -4 plus 3 times 8. 3 times 8 is 24. We're going to add a -4 to that. So that means a sub 9 is a positive 20. Let's go back to our original page here. And so what is a sub 9? A sub 9 is 20. Do you see how I did that? Totally didn't plan it to be that. That easy to change that question mark. All right. That's pretty much it. I want to say that this question is a little bit more on the difficult side. So I'm going to put a little star next to it. Hint, 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 hint. You catch my drift. It's going to be a very important question because not only do you need to use the formula, you need to use the formula multiple times. You need to think back to prior knowledge of solving system by equations. This is a really, really, really good possible test question or possible quiz question. All right, beautiful people, this wraps up this video. As always, thank you so much for watching, and I will see you in the next one. And you guys, thank you again so much for bringing my attention to the hiccup in part 2. I apologize. But if that ever happens ever again, please don't hesitate to reach out to me because I want to be able to provide that information for you without any glitches. All right, I'll see you in my next video. Bye.